Hey, this is Mr. Allred. I want to talk to you about linear equations of one variable. This may be a new topic to you, or maybe you need a refresher. But let's just kind of go through, first of all, what a linear equation of one variable might be. So, first of all, it's an equation, which means it's two expressions separated by equals. So a lot of times people try and solve something when it's not even an equation. So if there's not an equals in the statement to start with, it's not an equation. But we would only have one variable. This could be x, it could be y, it could be s, it could be anything. The variable has no exponent, so you won't see an x squared or an x cubed. The variable has no root, so you won't see the square root of x or the square root of x minus 2. And if there's a fraction, there's no variable in the denominator. So it's not a problem to have a fraction, but it has to be a fraction with a denominator being a number, not over x, but maybe over 5. So basically, you're going to see the operations in some form of add, subtract, multiply, and divide. You might see parentheses as well. So, a couple of examples here. 5x plus 4 equals 6x minus 7 is linear. One variable, x, no exponent, no root, no denominators, all good. The second one, 4 over x plus 5x equals 7. That's not linear because you're dividing by x. It's in the denominator. And the last one, x squared plus 5x equals 2x minus 5. The problem here is the x has an exponent of 2, so the x squared keeps it from being linear. And we will solve questions of these two forms, these nonlinear forms. We'll solve equations of them eventually. But we'll need to know how to solve linear equations before we get there. Okay. So I'm going to give you a set of steps to help you get comfortable solving linear equations. You may not have to do all of these in every equation. You'll see a lot of ifs here. But if fractions exist, you'll multiply the entire equation by a common denominator or at least common multiple. What this does is it actually lets you get rid of fractions. I see a lot of people trying to add fractions together by making a common denominator, and then they're still working with fractions. What this first step lets you do, if you're clever, is get rid of the fractions altogether, and then you can solve your equation. So if parentheses exist, this is step 2, we'll use the distributive property to get rid of them. Because eventually we're trying to get our variable by itself, and if there's parentheses there, that keeps us from separating it from the other stuff around it. So now we have step 1 we get rid of the fractions, and step 2 we get rid of the parentheses, which means all the terms kind of stand by themselves and can be moved around very easily. Okay, so then on the left and right hand side we're going to collect like terms if they exist. And then we will add or subtract on both sides to get our variable terms on one side. So maybe all of our x's on the left and all of our non-variable terms on the other. So maybe our numbers on the right. Could be vice versa. Okay. And then if there's a coefficient in front of the variable, we'll divide both sides by it. And then we have our solution from the linear equation. Okay. So all of these steps are designed to help you get your variable along so that you get x equals a number, okay, or y equals a number. Steps 1 through 5 are the steps we use the most, but there's no guarantee in any problem that you will have all 5 of them. Step 6 is the only one I can tell you that you always have the ability to do, although it's probably the one that we do the least, because if we feel good about our solution, usually we just stop, or if we've got a lot of problems, it feels a little overwhelming to check our answers. Okay, but let's use these steps. Let's go to an example. So this is my first example. It's 3/7 times the quantity of y minus 2. Then minus 2 equals -5. So I have a left side, I have a right side, there's an equals in the middle. But the first thing I notice is that from step 1, I see a fraction. Okay? And that's over here with the 3/7. And I see that denominator. And there's nothing too crazy going on here. But the least common multiple, since there's only one fraction, is 7. Okay? So what I'm going to do is I'm going to take my entire equation and multiply every term by 7. So that means the term that's 3/7 times y minus 2 will get hit by 7. So I'm going to write that under here. 7 times 3/7 times y minus 2. And then I will have the 7 times the -2 there. So that will be, how should I put this? Let's put it as minus the 7 times 2 equals, and then it will also hit the -5. So we will put the negative there, since that's a sign. So we'll have 7 times 5. And what happens is, way over here, where I have the 7 and the 3/7, it canceled out. So I don't have to worry about making everything into sevenths. Okay? So let's clean that up real quick, and we'll do it this way. 3 times y minus 2 minus 14 equals -35. Okay? So now we have an equation with no fraction, which is good. So we will, let's say we're going to use the distributive property now to get rid of these parentheses, distributive property. So we're going to take the 3 and we're going to push it into every term inside the parentheses. So I'll have 3y minus 6 minus 14 equals -35. Then I can collect like terms. And those like terms are -6 and -14. So now I have 3y minus 20 equals -35. So I've done step 1, 2, 3. This is now step 4, where I'm going to add, subtract across the parentheses, across the equals. So I need to get the y terms by themselves, which they are over here, but I need to get this -20 away, so I'm going to add 20 to both sides. That lets me bring down the 3y, but the -20 and the +20 cancel each other out. And now I have -35 plus 20, so I have 3y equals -15. I'm going to slide this up a little bit. So the last thing I will do is I will divide by the coefficient, which is what's in front of the y. So I'll divide by the 3 on both sides, which gets the y completely by itself. So I'll have y equals -5. And then in theory, I could take this answer way back up top and plug it in where the y is and see if the left and the right side balance. Okay. If it does, I've done a good job. If it doesn't, I need to try my problem over again. Okay. So we've walked through all those steps. So let's see something else that could happen. And you can pause at any time. But here, sometimes you're solving an equation and it doesn't go the way you expect it, even though you do everything right. So what we're looking at here is sometimes when you solve, the variable may cancel out. Okay, so you may start with an x on each side, or on one side. Well, that wouldn't make sense if it was on one side. But if you have multiple x's, they may add together and just disappear, which just leaves two numbers on each side, and you could either continue trying to solve but you can jump to your answer really quick. So if you get down to just two numbers and they're equal, that's called an identity, which basically means the left and the right side were really equal to start with. It means any number or any real number you pick to plug in would balance the equation. Now, if you get down to two numbers and they're not equal, that's called a contradiction because they're not the same and they've got an equals between them. This means that nothing will work, no solution. So there's nothing you could plug in that will make the left and the right side balance out. So that's where we just throw some gibberish down on the paper and it doesn't make sense. So when we start trying to solve it, it just doesn't work out for us. Okay. So let's see an example where that comes up. Okay. So I have the problem here. It starts off with another one with fractions, but it's the fraction of 4x minus 3 over 2 plus 7/4 equals the fraction 8x plus 1 over 4. So let's go through our steps because we don't know what's going to happen when we start. But we have fractions. So we're looking at step 1. And we see 2, 4, 4. It'd be nice if they weren't there. So the least common multiple, or the common denominator between 2, 4, and 4 is 4. So I'll multiply both sides by 4. And that means there's 3 terms in here that get hit by 4. So let's write it out. You don't have to write every single step that I write, but it will help you understand what's going on. So 4 times the fraction of 4x minus 3 over 2, then plus 4 times the fraction 7/4 equals 4 times the fraction 8x plus 1 over 4. So looking at this, over here, the 4 over the 2 reduces down to be just 2. So that's kind of created a fraction, a distributive property for us, but the 4 over 4 goes away, and the 4 over 4 on the right-hand side goes away. So now I no longer have a fraction, and let's just go ahead and rewrite it. We've got the time. So we've got 2 times the quantity of 4x minus 3 plus 7 equals 8x plus 1. And I could see you not wanting to rewrite that. But now we can use the distributive property if you haven't already. And we will push that 2 into the 4x and the minus 3. So we'll have 8x minus 6 plus 7 equals 8x plus 1. Let's go ahead and combine some like terms on the left-hand side, which are the negative 6 and the 7. So if we do that, we'll have 8x plus 1 equals 8x plus 1. Aha! So now we can start trying to collect our, add, subtract on both sides. And you could do this in one step or two. But we definitely want to get our x's together. So we might say subtract 8x on both sides. And they go away. And that brings us down to 1 equals 1, which is always true. Which means it is an identity, which we can also list as all real numbers. So that's our solution. We call it an identity, which means basically the left and the right hand side were the same, just written a little bit different. We can subtract 1 from each side and show that it's 0 equals 0. But if we went back to the original problem up here, and let's use a different color, green. So if we looked at the x on the left-hand side and the x on the right-hand side, since it's an identity and we said the solution is all real numbers, that means if we plugged in 1 for x, the left and the right side would balance. If we plugged in 5, the left and the right side would balance. If we plugged in 100 or negative 100, it would balance. Okay, now let's go do some practice.